Right, greetings and welcome to the Dr. J Vlog series. It is Thursday, June 12th, 2025, and on Thursdays we talk about knowledge and science. So today we're going to be talking about 5 of the major scientific concerns that we've identified with respect to the health and well-being of the oceans. As you know, many of you already, that this week we've been talking about the oceans from a number of different perspectives. Each of the different vlogs has addressed oceanic issues in different ways. And so today I'm just going to be talking about the top 5. Well, I don't know if it's the top 5. There's so many issues that we could discuss, but I've identified 5 specific issues that I want to highlight with respect to the research that's been done on the oceans, the experts, the oceanographers, the marine life specialists, and so on. And the first issue that I want to identify is this link between the oceans. And I've talked about this already this week, but the links between the oceans and human health and well-being. So broadly speaking, there's an intimate link between, our human health and well-being and, of course, our relationship with our biospheres and, in particular, the hydrosphere. So the ocean provides key resources, obviously, in terms of human health, in terms of our well-being. We've talked about all of these issues: food and oxygen, livelihoods, blue spaces, which I dealt with, and even medicines. So the first concern then that I want to mention today from a scientific perspective, again, has to do with the problem of ocean acidification. That is, the global threats from carbon dioxide and the extent to which that accumulates in our world's oceans, and then ends up driving this process of ocean acidification, because this is becoming increasingly evident and something that we have to address. So as humans extract and burn fossil fuels and drive deforestation and so on, the CO2 in the atmosphere increases. And the levels in our atmosphere are considerably in excess of what they were in pre-industrial times. And of the released CO2, about 25% ends up being absorbed into the oceans, and then it interacts with seawater and forms carbonic acid. The process then has led to a reduction in the pH of the oceans. In other words, an increase in acidification and an alteration then of carbonate chemistry. So again, scientists have documented that the average surface pH of the ocean has already decreased by about 0.1 units since the beginning of the Industrial Revolution, or from an average pH of about 8.2 to 8.1. Now that may not seem like a lot, but remember, this is done on a logarithmic scale. And even more concerning is the fact that the oceans are predicted to see a further decrease of between 0.3 and 0.4 by the end of the current century. And since, again, pH is measured on a logarithmic scale, then that would correspond with a doubling in the acidity of our oceans by the year 2100. A wide range of organisms, from bacteria to fish, have been demonstrated already to be negatively affected by ocean acidification. And as acidification progresses, many organisms then have to invest additional energy to maintain their acid-base balance, their metabolic processes, and other biological functions, all of which then have direct consequences for their growth, reproduction, and survival. In particular, ocean acidification is sometimes referred to as the osteoporosis of the sea. That is, ocean acidification can create conditions that eat away at the minerals that are used by oysters, by clams, by lobsters, shrimp, all shellfish, by coral reefs, and other marine life, right, to build their shells and their skeletons. So that naturally increases their vulnerability and the odds of their long-term survival. And while ocean acidification was initially primarily seen as a threat to marine life, we're now quite confident that it's also increasingly a human health issue too. That has implications in terms of malnutrition and poisoning, implications in terms of respiratory issues, even mental health impacts, as I discussed the other day. And then there are obvious socioeconomic impacts potentially too, in terms of the jobs that are lost and in terms of the cost of ocean-related products. That is, scarcity, of course, drives up cost. And that means that increasingly, whatever the ocean might still be able to yield will be increasingly affordable only to smaller and smaller segments, or the wealthiest in our societies. Okay, so a second problem you've probably heard about as well has to do with the levels of mercury that we're seeing in the oceans, which can cause severe illness to marine life and humans alike. It's a pollutant that accumulates in the food chain and then reaches humans through the ingestion of fish, among other sources. So mercury emitted in the air eventually settles into the water or onto the land, where it can be washed into the water. And once deposited, certain microorganisms can change it into methyl mercury, and this is happening in the US and in Canada and quite frankly, globally. And as a result, what we know is that this ends up having, again, these adverse impacts on the fish, on the shellfish, on the animals that eat the fish, and then ultimately in terms of humans and our consumption as well. Okay. A third problem is related directly to climate change. That is the rising sea temperatures that we've been witnessing in recent decades. The average surface temperature of the oceans has risen about 1.5 degrees Fahrenheit since 1901, with particularly sharp increases since the 1980s. So in other words, what we're seeing is that the rate of warming has been increasing in recent decades as well. It's important to note, too, that the distribution of excess heat in the oceans is not uniform. That is to say, the greatest ocean warming is occurring within the southern hemisphere. And then that further contributes then to the subsurface melting of the Antarctic ice shelves. But of course, in addition, the warmer temperatures induce dramatic changes, too, in marine ecosystems, with severe and potentially lethal consequences for many species. That is, in addition, I should say, the ocean warming contributes to changing migratory routes, which then causes imbalances in food chains or disrupts the food chain. So, for instance, just raising the water raising the temperature by about 0.5 degrees centigrade kills off coral reefs. And healthy coral reefs are these kind of maternity wards and shelter areas for so many different species that provide, again, human food as well, and on which so many in the fishing communities depend. So these are vital. All right, then a fourth problem that I also discussed briefly early in the week is the problem of the overexploitation of available fishing resources. And again, that's the theme of World Ocean Day 2025, this year's theme. So studies indicate that there's been a considerable reduction in the populations of some species of fish. So I talked about this the other day as well. The overfishing of cod in the Canadian waters almost led to the extinction of the species, an almost unthinkable proposition back in the 1970s. In addition to overfishing, there's also a serious lack of fish activity management or adequate management, including problems with serious non-compliance of existing rules and regulations. So, and then among other things, there's the absence of the definition of the size, or how to regulate precisely the size of the fish at the time of their capture. Why is that important? This means that we run the risk then of overfishing juvenile fish, shall we say, or females with eggs, or who haven't gotten to the point where they can reproduce yet. this ends up being a recurring problem as well. So, again, overfishing in general is a problem on a number of different levels, but we have yet to officially and formally and internationally regulate our overfishing practices to any serious degree. I also want to mention too that the overfishing of species with long life cycles at the top of the food chains, like sharks and tuna, or species that are used for luxuries like in cooking or alternative medicines, these can also cause irreversible changes in the harmony and the balance of marine life. And indeed, probably the worst offenders of all, if we were going to boil it down to one main source, would be commercial fishing industry, because this involves a tremendous amount of waste, or the problem of what some of you may know is known as bycatch. So in other words, according to recent estimates, for every pound of targeted fish that are caught, up to 5 pounds of unwanted marine life may be unintentionally captured and then typically is discarded, wasted, destroyed. Furthermore, there are countless documentaries out there that illustrate the degree of human cruelty towards the many different forms of marine life, from accidental forms of entanglement to some forms of commercial fishing that would quite literally turn your stomach if you were to watch this, to the chemical runoffs and oil spills, to the final issue that I'm going to address, and that is the problem of plastics. Yeah, according to the Ocean Conservancy Organization, every year, 11 million metric tons of plastic enter into our oceans on top of an already estimated 200 million metric tons that are currently circulating in our marine environments. So whether, just in terms of wind-blown plastic bags or plastic straws that sort of wind their way into our gutters and then end up eventually getting washed into our rivers and streams and then deposited in the oceans, or just in terms of the massive mismanagement of plastic wastes, regardless, there's a ton of plastic, literally many tons, entering the ocean every day. In fact, it's roughly the equivalent. Here's one way to think about it. It's roughly the equivalence of dumping one New York City garbage truck full of just plastics into the ocean every minute of every day for an entire year. And of course, that much plastic's bound to have an adverse impact on our ocean ecosystems. From the tiniest plankton to the largest whales, plastics impact hundreds upon hundreds of different species in our oceans. Plastic's been found in more than 60% of all seabirds, and in all 100% of all sea turtle species as well, that end up mistaking plastic for food, among other things. And when animals ingest plastic, that can cause life-threatening problems, including digestive blockages, internal injuries, problems with nutrient uptake then and feeding efficiency, chemical contamination in some cases, and reduced fitness. Not to mention habitat destruction and a reduction in biodiversity. And then finally, there's the increasingly problematic issue of plastics breaking down into microplastics, which end up, of course, not only affecting human beings, we're experiencing this problem directly ourselves, but can cause all kinds of problems too with marine life in general. And again, the effects of these microplastics are we're still learning about them, but they appear to cause developmental delays, reproductive issues, and increased susceptibility to disease. So all negative impacts. But let me end on a slightly more optimistic note. There is some good news these days, too. There are serious efforts afoot to reduce plastic consumption, especially single-use plastics. I'm sure most of you probably live in areas now where they no longer use plastic bags for shopping. We're supposed to use reusable bags, that sort of thing. I know there's a raging debate in some parts about the use of plastic straws. To me, it's a no-brainer, but you know, I don't want to get into the politics of it all. But increasingly, I think that the most viable solution or the longer term solution is going to be the development of biodegradable alternatives. And so that's where, and eventually when somebody's able to market that efficiently and, turn a huge profit, that's, we'll end up hopefully eliminating many of the single-use plastic practices that we currently engage in. And we're indeed improving our waste management and regulation and recycling practices all the time as well. So to me, it's like any of these longer or larger scale trends, like people didn't want to wear seatbelts initially, or people smoked all the time. But eventually, with enough knowledge and information, and once people are able to develop, efficient alternatives, we were able to switch our human practices. I think that's going to happen inevitably with plastics as well. And then there are some really cool technologies and enzymes already here or in development that help break down and degrade plastics more efficiently. So I'll leave a link then in the description below in terms of a tidy little National Geographic video on the discourse of keeping our oceans as clean as possible or as free from plastic as possible, not to mention other forms of pollution. Okay, so that's something we can definitely solve, I think. It's one of the more solvable problems, but again, it's going to take a concerted effort and a little bit of change in our habits and so forth. But it's not nearly the type of wicked problem that plagues us in other realms. So I do have, as much as I sound like a negative Nelly today with respect to the problems of plastics, I do see this as an area where we can actually solve the problem, at least the human aspect of it, and in our lifetimes. Okay, that's it for today. As ever, may you and yours continue to create peace in your lives, nurture love in your hearts, and dole out hugs in abundance. Hope to see you tomorrow.